Okay, so this video is going to be on the amount substance, which is 3.1.2 on the spec. It's part of your Unit 1 exam, but also useful for the Empa, and this is going to be the calculations. So Avogadro's number is the constant for 1 mole. It's the value of 6.023 times 10 to the 23, and this is the number of particles that we're referring to when we're talking about a mole. The equations that we need to know include mass, which is the number of moles equal mass over mR, and in this instance mass is in grams. The concentration is C equals N over V, where the concentration is in moles per decimeter cubed, moles of course is in mole, and volume of course is in decimeters cubed. Finally then, we have the ideal gas equation, and this is PV equals nRT, where P is the pressure in pascals, V is the volume in meters cubed, so this is different to usual, which is normally decimeters cubed. That should be in N, and that should be number of moles. R is the gas constant, which is 8.31, but this will always be given, and don't worry about the units. And T is temperature in Kelvin. So I said that the volume for the ideal gas equation is different, so it's useful then to know the volume conversions. So I've broke it down, so centimeters cubed to decimeters cubed is times by 10 to the minus 3, or if you don't like using that sort of terminology, it's dividing by 1,000. And decimeters cubed to meters cubed is also times 10 to the minus 3, or dividing by 1,000. So then to go from centimeters cubed to meters cubed, we basically just divide by 1,000,000, or times 10 to the minus 6. So we also need to know about atom economy. This is used as a measure of how much useful product is formed. So the mass of the desired product divided by the mass of the total reactants times by 100 as it's a percentage gives us this atom economy. Next we need to know the percentage yield. This is how much product is actually made from our reactants. And this is the actual mass of the product divided by the theoretical maximum mass of the product. And again this should be times by 1,000, times by 100, but for some reason my formatting hasn't gone so well there. Finally then we have the percentage error, and this is the error of the equipment divided by the measurement you made by the equipment times by 100. So for example, a titration, you would have your error for your burette divided by your titer, say 22.5, times that by 100, and that's your percentage error for the burette. But that's just an example. And that's all you need to know for the calculations of the amount substance.